Yes? Let me
Yes,
take out your page. Just a second, I'm sharing the screen. This is your answer. This was it we were doing. Wait, I'm just looking for the page. Where is the page one? I think this is the page, that one, right? Properties on whole numbers, closure property we had done, right? Closure property, I just revise this before we move on ahead. Closure property says that if we add two numbers, the answer is also, if we add two whole numbers, the answer is also a whole number, okay? This, hello? Hello, can you hear?
yes, ma'am.
So closure property says that if you add two whole numbers, the resultant that you get is also a whole number. Okay? The sum of two whole numbers is also a whole number. This is what the closure property tells us. Okay? If you multiply some number with, if you add some number to whole numbers, the answer that you get is a whole number. And it applies in the case of multiplication also. Okay? If you multiply two numbers, the answer that you get is also a whole number. Even if you multiply a number with the whole number 0, so you get 0 only. Okay, 0 is also a whole number. Next property is commutative property. Commutative property says that if you add two numbers in any order, either a plus b or b plus c, if you add them in any order, the answer is always the same. Okay, in which a 2 plus 3, if you do it, it is 5, and 3 plus 2 is also 5. Okay, like here. And same is the case when we multiply two numbers. 5 into 3 is 15. Okay, so if I do 3 into 5, that will also give me 15. Okay, then next we studied was associative property for addition and multiplication. Now this was that when you add or multiply in making into groups, taking groups in any order. Suppose if you have taken two numbers in one group, okay, and added with the third number, and on the other side you have taken other two numbers in one group and added with the third number, your answer is the same. Are you understanding? Yes, I have three numbers here, A, B, and C. In any order, if I group them, either I group A and B together and add with C, or I group B and C together and add with A. Okay, the answer that I get is always the same. This property is called associative property, right? And it holds true for addition also, it holds true for multiplication also. Okay, children? This is just a recap of what you have done in your previous class. Okay, then next was the distributivity of multiplication over addition. Now, distributivity of multiplication over addition. Okay, so we have 7 multiplied with, inside the bracket we have 3 plus 9. So we call it distributivity of multiplication over addition, right? So that means 7 multiplied by 3 plus 9. So when you do 7 into 3, so what do you do? 7 will first multiply with 3, then 7 will multiply with 9 also. Okay, so you have both sides, answer will be the same. Suppose if you do 9 plus 3, 9 plus 3 is what? 12. 12 into 7 is how much? 84. Okay. Now, if you try this one, 7 3s is 21, and here you have 63. Okay, and when you add them, what do you get? 3 plus 1 is 4, and you get 84. So you get your answer equal.
Yes,
Are
ma'am.
you understanding? Okay, same way, let's see for another example. 8 multiplied by 5 plus 9. So first 8 will multiply with 5, and then 8 will multiply with 9. Okay, 8 multiplied with 5 plus 8 multiplied with 9. Okay, so if you work out this answer and you work out this answer, both answers will be equal. Okay. Okay, the next property was identity for addition and multiplication. Identity means the identity element. Like identity, if I add or multiply with some number, I should get my same number back. Okay, my number should not lose its identity. Are you understanding? Like suppose if I add some number with 0, 0 is a whole number. If I add a whole number with 0, I get my same number. 5 added with 0, I get 5 only. Okay, so that means my number did not lose its identity. वो 4 से कुछ और नहीं बन गया है ना, it's 5 only. It did not become -5. It did not become 6. It did not become 7. It remained 5 only. So that number with which I added it, that number is called additive identity. That is, here 0 is the additive identity. Right? Are you understanding?
Yes, ma'am.
Same way, in case of multiplication, 1 is the multiplicative identity. It's not additive identity. It's called multiplicative identity because we are multiplying this now. Okay. This is called multiplicative identity. So when I multiply any number with 1, I get the same number. My number does not changes. Okay. My number retains its identity. So this 1 is called multiplicative identity. Okay, 0 is the additive identity and 1 is the multiplicative identity. Okay. Then next we did division by 0. Okay. Any number divided by 0 is never defined. Okay, that's, we call it as infinity. We don't get any number. That's not defined. We cannot divide any number with 0. But if we divide 0 with some other number, then our answer always comes 0. If we have 0 like this inside and we divide it, our answer always comes 0. Okay, but if we divide like this, suppose like this, then this is not defined. Right?
Yes, ma'am.
Okay. Find the sum by suitable rearrangement. Okay, now suitable rearrangement means by adding those numbers which make our work easier. Okay, suppose if I have, like this, you can say, if I have these two numbers, if I multiply 50 with 2, then I get 100. And it's easy to multiply them. And I can quickly do my calculation. Is that? So by suitable rearrangement means I have to arrange those numbers in such a way that my work becomes easy. Okay, so here as it is, I took this number and this number. Then I got 1200 and I added 1200 with this. This was pretty simple. Okay. Had it been, if you try other way, if you add any other two numbers, you can check out whichever you find it easy. Right? But the numbers in which we have zeros at the end, in ones place we have 0, or in tens place we have 0. If wherever we have zeros in the end, that makes our calculation easier. Isn't that? Is it? When you have to multiply some number with 100, with 1000, so what do? You just put that many zeros at the end. Is it?
Yes, ma'am.
So multiplying with those round off numbers is much easier. Like here also 125 multiplied with 8. When I multiplied this with 8, I got 1000. So multiplying by 1000 is easy, right? So that is by suitable rearrangement. Whichever way suits us, we do that. Okay. This was your question. You were saying the 13 into 108. So instead of taking 10 plus 3, it's better to take 100 plus 8. Right? Okay, now moving ahead, let's see what do we have next. Okay, do this sum. I'll give you one or two sums. Let's see if you are able to do. Okay, let me see. Here you have to solve these. 54279 multiplied by 92 plus 8 into 54279. You can use the distributive property here. What was the distributive property? That if I multiply distributivity of multiplication over addition, like this it was, any number multiplied with the sum of other two, you get A into B plus you get A into C. Right? Okay. So this is in that order. This is A into B plus A into C. Yes, do please. Okay, done the first one. Yes, children. Who has done the first one? Now look here, see, how will you do the first one here? Please pay attention. Now see, you can see this is one term, this is another term, okay? This is just split into like this number multiplied with this, okay? I like suppose I had 6 here and I have split 6 into 3 multiplied by 2, okay? This number is split into like this, right? Okay, now I can see I have this number 54279 here also, 54279 here also. So that means this number is common in both the terms. Okay, so I will take this number out because this number is common for both the terms. So I take this number out and what I have left inside, that is 92 plus 8. Okay, so that's 92 plus 8 is left inside. So 92 plus 8 is 100, is it? And 100 will get multiplied with this 54279. And here you can get your answer. When you have such numbers to multiply, you just put that many zeros at the end. Is it? Okay. Now similarly do the next one.
Done, ma'am.
Okay. Tell me what is that?
297
Hmm.
and 17 plus 3 in brackets.
Yes.
And then 297 times 20.
Yes. Okay. So what do you get finally?
5,940.
Very nice. Okay. Good. Okay. Bhavesh, you got your answer? Yes, Bhavesh. Bhavesh, are you there? Okay, now read the next question, Lakshita. Read this question. A vendor supplies. Read this one.
A vendor supplies 32 liters of milk to a hotel in the morning and 68 liters of milk in the evening. If the milk costs 15 per liter,
Rupees
how much
15. It's
rupees
rupees 15.
rupees 15 per liter, how much money is due to the vendor per day?
So did you understand the question?
Yes, ma'am.
That means in the morning, the vendor supplies 32 liters of milk to a hotel. And in the evening, he supplies 68 liters of milk. Okay. And if 1 liter costs rupees 15, then how much money should the vendor get per day? Okay.
Yes,
For the milk he's selling. So how will you find out that?
15 times 32 plus 68 in brackets.
Okay. Then,
Then 15 times 100.
okay. Now suppose if you add the whole of the milk that he's supplying in a full day. If you add in the morning he gives 32, in the evening he gives 68. If you add both of them and you get the total amount of milk that he's giving in one day and you multiply with the cost of the milk. Won't
Yes,
that be easy?
yes, ma'am.
Yes. So we just added 8 plus 2 gives us 10, then 9, then 100.
100,
Okay, that's 100 liters of milk.
1,500, ma'am.
So that means the money due to him is 1,500. For his milk selling, he should get rupees 1,500 per day. Okay. Okay, let me see what else we have in this chapter. Hmm. Okay, beta, this whole numbers concept is still here only. Nothing more than this. Okay. Okay. Now we don't have anything more in this chapter, but I'll give you homework questions for practice, right?
Yes, ma'am.
But I'll give you late when I finish with all my classes. No, I have classes till 8 o'clock. And after that will be the dinner time, and then only I will get time to give you homework, right? Okay.
Okay.
So by the time you must revise what you are doing, what we have done in the class. Okay. Okay. After this, I'm just looking at the next chapter.
What
Yes.
is the next chapter?
Please say.
What's the next chapter?
That's what I'm looking into, beta. Okay, we have playing with numbers also, but I'm giving it a halt because before that also we did knowing our numbers again with numbers. So number concept is one more that will take it afterwards, okay? Because too much of
Okay.
numbers will be boring then.
Ma'am, are we having geometry?
Yes, we have geometry, beta. We have some basic geometrical ideas. We have elementary shapes, just the very
Ma'am,
basic of it.
Can we
Ma'am,
do
I think we have integers. Wait,
Want to do
Can we
integers?
do-
Integers is, yes, it's here integer. You want to do
ma'am,
integers?
quadrilaterals.
Yes, we have integers. We don't have quadrilaterals. Quadrilateral that comes all in the geometrical ideas only. Okay?
Ma'am?
Ma'am, all
Yes.
those are part of geometrical only.
Yes, that comes in the geometrical ideas, not geometry, geometrical ideas. Okay, first you will be studying about how many types of angles are there, how many types of triangles are there.
Ma'am, I know about that.
What?
Ma'am, I know about geometry.
I'll just take out the names of the topics. Okay, basic geometrical ideas we have. Listen first.
Ma'am,
Elementary shapes, integers, we have fractions, we have decimals, we have data handling, we have mensuration where you have perimeter and area sums, we have algebra, we have ratio and proportion. Okay, right?
ma'am, in geometry, for example, obtuse angle, acute angle.
Yes,
right
that also you have the introduction part you have in basic geometrical ideas, and constructing of the angles you have in your practical geometry chapter. Okay. How do you construct with the compass?
Ma'am, construct with triangles and scale stuff.
Huh. Okay. So we'll take integers now. Right, children? Shall we take integers?
Ma'am, I thought of geometry.
You want to take geometry now first?
Yes, ma'am. I love geometry.
Okay, then we'll do for basic geometrical ideas. Okay?
Okay, ma'am.
The name of the chapter is Basic Geometrical Ideas. Okay. See now, in this chapter, we will first study about types of lines. Now, anything in the geometry starts with a point. Now, this is a plane surface. Can you see? It's a white paper here. It's a blank surface, right? And I just put a point here. Okay. So, every geometry starts with a point. From this point, if I have to make a line, how many lines can pass through one point? How many lines can you think of that can pass through one point?
Infinity.
Yes, so many. You can make as many number of lines you can make, no? Infinite number of lines. Okay?
Yeah, ma'am, but
Infinite number of lines can pass through one point, one single point. And how many lines can pass through 2 points?
ma'am, one line, like
Yes,
it
one line. Okay?
one point to another.
Okay? There is only one line that can pass through the 2 points, but from one point, infinite lines can pass. Okay, so this first was the point. Okay, now if I stretch, I have this point and I stretch a line which goes on further, further, further. It
And
has
that's called
no
ray.
end.
That's
That's,
called ray.
it has no end. So we call it a ray. Okay, the very famous example is the sun ray. Okay, a ray has one end point. It has a starting point, but it has no end point. Okay, the sun rays comes out from the sun, but we don't see them terminating anywhere. Isn't that? We don't
Yes,
see them stopping anywhere. So that's sun ray. So this type of line which has one end point given and there is no other end point, we call it a ray. And such line which has two endpoints, a starting point also and a finish point also, we call it a line segment, right? We
yes.
call it a line segment. And we can also say that this line segment is a part of this ray. Okay, if I take another point here and I take this much of the part of it. So line segment is a part of a ray also. That also we can say. Okay, then what else do we have? If we have some line here which extends towards right side also and it extends infinitely towards left side also. So this type of line is called,
Line.
we call it a line, just line, as you have in maths number line. You have number line?
Yes, ma'am.
You have studied about number line. We have zero in the middle. This side we have all positive numbers. Then we have zero. Then we have -1. Have you seen this?
And that's a line. And
That's a line because it has no right end. It has no left end. Okay, so we
it
call it
has
a line.
no starting point, no
No
starting
end
point,
point.
and it continues to infinity at both the sides.
Yes, very good. Okay. Okay, and we talk about plane. Plane is a two-dimensional surface. Like you can see this board. Okay, this is the whiteboard where I'm writing. So this is a plane surface. Okay, any two-dimensional surface. Why I call it two-dimensional? Because it has only two dimensions. One is the length like this, and the breadth. Okay, it has length and a breadth. So we call it two-dimensional, like a paper in your notebook. Okay, a paper of your notebook is a two-dimensional, right? It has length, it has breadth. But anything that is three-dimensional, it's something like a box. You must have seen a shoe box, isn't that? So
And
what is a shoe box? It's a box kind of thing. That means it has a length, it has a breadth, it has its height
Height.
also. Okay, so that is called 3D shape. These shapes are called 3D shapes. But why we call it 3D shape? Because it has length, it has breadth, it has height. Three things are there, right? We call it 2D shapes because here we have only two things, length and breadth. Okay? Okay. Then we have parallel lines and intersecting lines. Now see what are parallel lines. Parallel lines are when two lines are side by side and they have equal distance between them. Okay, at every point, we see a equal distance between them. This distance never gets less, never gets more. It's equal everywhere. So those kind of lines are called parallel lines, right? Like the lines of a railway track. Okay, have you seen a railway track? The two tracks are just parallel, right?
road.
And yes, and What do we see? Another set of lines is intersecting lines. See, lines have two options. Either they are parallel or they are intersecting. Okay. So intersecting lines means when two lines cut each other. That we call as intersecting. And this point where they intersect is called point of intersection. Okay. Point of intersection. Are you understanding?
Yes, ma'am.
We have two lines that intersect is called intersecting lines, and the point where they intersect is called point of intersection. Okay. Okay, now whenever we write, suppose this is, I say, a line segment, I'm giving it a name AB. So how do I write line segment? Whenever I'm writing line segments, I put a bar like this. This is just, we denote line segment with this bar. Okay? Okay?
Okay.
Huh.
Okay.
Suppose if I tell you AB is some line segment, so I will write like this. That means this bar shows that this AB is a line segment. That means it has a starting point, it has its end point. Okay? It has a starting point, it has end point, and the names are A and B. Okay? Right, children?
Yes, ma'am.
Huh. So this much for today, bache. The class time is over. I have another class waiting.
Ma'am, if it is a point, we are gonna, and its name is A, we are gonna keep a dot at up and write A down.
Hmm.
That, right?
That's a ray. That's a ray. If we just have, A, B like this, and you call it a ray. So we write it like this. Okay?
Okay, ma'am.
Huh. So while writing, we have some symbols here. We'll talk about it when we'll do the questions and we'll get to understand.
Ma'am, even angles also have some symbols.
Okay, yes. Yes. Okay, so children, thank you for today.
Thank you, ma'am.
See you in the tomorrow's class.
Okay, ma'am.
Oh,
Have a
no,
good day.
tomorrow is a holiday. Tomorrow is a holiday on account of Eid.
And Ranjan.
Eid ul Fitr.
Oh,
Okay?
bye, ma'am. Have a good day.
No, I think you won't be
Bye,
having
ma'am.
it. Bye, beta. Bye bye.
Bye, ma'am.
Bye.